Hello, welcome back to PhysioDesigner tutorial series. In this tutorial, we will update the model created in the previous tutorial. The simulation showed excitation propagation on a ring, or a solid torus. Remind that we utilized a volume object of the ring to create the model, which is eventually composed of many instance modules of BVP model and gap junction model. One BVP instance module has 6 directional connections with neighboring instances via a gap junction instance module, as shown in this slide. The simulation in the previous tutorial showed bidirectional propagation of action potentials, which were evoked by an external stimulus. They collided at the opposite side of the ring and vanished. In this tutorial, by adding the second external stimulus, we try to simulate unidirectional excitation propagation, that is, action potentials rotate on the ring in one way. The second stimulus will be inhibitory, so that the stimulus can stop the propagation of action potentials at one side. Then action potentials which go to the other direction will survive without colliding to oncoming action potentials. Let's begin modeling. We start with a model previously created. Here are templates modules of BVP model and gap junction model. Already instances of those templates were created utilizing the ring shape volume object. And one stimulus was already given to a couple of instances of BVP. Firstly, let's define the second stimulus side on image viewer. Right-click the torus module and select Show Image. On image viewer, go to select voxels at the menu. In this time, let's select several voxels at lower part of the ring for the second stimulus site. Then save it and close image viewer. Next, copy the stimulus module to create the second stimulus. After pasting it, change the name of the newly created module. Adjust the parameters of the second stimulus. Duration will be extended to 50, and the step, which is a kind of amplitude of the stimulus, will be -2, so this is inhibitory. Then span an edge from the second stimulus module to the BVP instances. In the dialog, load the file defining the second stimulus site. Before saving the model, lengthen the first stimulus duration a little bit, by which more action potentials will be evoked. Okay. Now let's save the model and call Flint to run a simulation. Adjust parameters for simulation on Flint. The sampling rate will be 1 point per 10 steps. And in the second tab, set X to filter the variables to be dumped in the simulation result file. By this filtering, we can reduce the size of the result file. Then click Run button to start a simulation. This takes time, so let's skip on the movie. Simulation was completed. Click Detail button and export the result into ISD format. Now, let's launch PhysioVisualizer. At first, create a data layer, then set name, and select Flint format, that is ISD format, and select the file. Minimum and maximum values are -2 and 2. PQ names should be X, and the size of XYZ are 24, 24, and 4. Set a directory to store VM files. OK. Close the dialog. Sliding the time slider knob, you can see the way of the action potential propagation. 3 action potentials were generated by the first stimulus, and they propagate to both sides at first. Some of them disappeared because of the second stimulus, and finally, 2 of them survived and kept rotating on the ring. Let's change the view mode to raw voxel mode and open time course graph window. Observing the time course at the second stimulus site, you may notice that there are 3 small peaks at the beginning of the graph, which correspond to the action potentials came to this direction from the first stimulus site. Due to the inhibitory external input, those action potentials were blocked. Then there are two large action potentials following. Where did they come from? Let's see the dynamics. Click play button to start automatic play. It is interesting to notice that the first big action potential of the red curve is actually the second action potential came down from opposite way. The actual front runner of those three action potentials was countered by the refractoriness of the third action potential, which has just vanished. Eventually, in this case, two action potentials could remain and kept rotating on the ring. That's all for this tutorial. In this way, excitations of the ring object composed of a lot of BVP can be tested. Thank you for watching until the end. See you until next time. Goodbye.